Hello, my friend, and welcome to the Sleepy Scholar. Tonight, we are going somewhere strange and somewhere gentle, both at once. Tonight, we are going to fall slowly, safely, only in our minds into a black hole. Not the kind from movies, with sirens and shouting. A quieter kind. Think of a black hole not as a monster, but as the deepest hush the universe knows how to make. A place where space folds so far in on itself that it forgets how to let anything go. A held breath, billions of years long. A silence with a shape. If you're here tonight, you've probably had a long day. Maybe your mind is still turning over a conversation, a task left undone, a small worry that keeps circling back like it forgot where it parked. That's all right. You don't need to solve it tonight. Some minds don't want counting sheep or ocean waves. Some minds would rather drift off wondering about something vast and old and quietly beautiful. If that's you, you're in the right place. There is nowhere else you need to be tonight. No test at the end of this, no quiz, no need to remember a single word. We're simply going to wander gently, unhurriedly, toward the edge of one of the strangest places that exists, and then just let the strangeness rock you to sleep, the way the ocean rocks a boat that's finally allowed to stop rowing. If these slow, sleepy journeys ever help you rest, you're welcome to like or subscribe, not because you owe anything, but because it helps other tired, curious minds find their way here too, the way a lit window helps a traveler find a house in the dark. Now, let's begin to settle. Let your shoulders drop, just a little, away from your ears. You don't have to do anything more than that. Let your jaw soften. There's often a tightness there we don't notice until we let it go. Let your breathing slow, not by forcing it, just by noticing it. The way you'd notice a tide going out on its own schedule without your help. You don't need to follow every word I say. You don't need to remember any of it. Nothing here is a test, and nothing here requires you to stay awake for it. In fact, if you drift off in the middle of a sentence, that will mean this worked exactly as it was meant to. Your body already knows what to do with a voice like this one. It's done this before, long before you had words for it. So let your eyes rest if they haven't already. Let your hands go heavy and still. Let the room around you soften at the edges, the way a photograph softens when it's a little out of focus, comforting, not blurry, just unhurried. And now, let's begin to wander. Far out in the dark, past the last star you can name, there's a place in space where gravity has quietly won every argument it's ever had with light. We call it a black hole, but the name is almost a joke, because it isn't a hole in the way. A hole in the ground is a hole. It's not empty. It's the opposite of empty. It's a place where an enormous amount of asterisk, something has folded into a very, very small amount of asterisk somewhere. Gravity, taken to its final, patient conclusion. A black hole is what's left when a star that spent millions of years holding itself up against its own weight finally gets tired. Stars are always in a kind of standoff, the heat from their core pushing outward, gravity pulling everything inward, a balance that can last for ages. But when a truly massive star runs out of fuel to keep pushing, gravity simply wins. The star collapses inward, faster and faster, until what remains is packed so tightly that not even light, the fastest thing in existence, can climb back out of it. Somewhere, right now, tonight, this has already happened quietly to a star far older than the ground beneath your house. Its light took so long to reach anyone that by the time we might have noticed it dim, the news was already ancient. There is something comforting in that. The universe keeps its bigger secrets on a very slow clock, much slower than any deadline you're worried about tonight. But that is only one small part of the story. The edge of a black hole is called the event horizon, and it might be the strangest boundary in all of existence, because it isn't really a boundary at all. There's no wall there, no shimmer, no line drawn in space. If you were falling toward one and you drifted past that edge, you might not feel a single thing change. No thud, no snap, no flash of light. You would simply keep falling, the same as you were falling a moment before. The event horizon is defined only by one quiet fact. Past this point, escape has become mathematically impossible. Not difficult, not dangerous. Impossible, the way it's impossible to unring a bell or walk backward through yesterday. Space itself, past that line, is falling inward faster than light can travel outward. So even light, sprinting its fastest sprint, loses ground with every step. Think of how many boundaries in your own life feel dramatic from a distance, and quiet up close. A birthday, a big decision, a threshold you worried about crossing for weeks. Often, the moment itself passes so gently you barely notice it happening. The universe, it turns out, agrees with you. Even its most absolute doorway is silent when you finally walk through it. There's something else worth resting on for a moment. If you were the one falling, not someone watching from a safe distance, but you yourself, drifting toward the horizon, something odd happens to your sense of time. To you, in your own little bubble of experience, everything would feel completely normal. Your heartbeat wouldn't slow. Your thoughts wouldn't stretch out. A minute would still feel like a minute. But to someone watching you fall from far away, through a telescope, safe and distant, you would appear to slow down, slower and slower and slower still. As you approached the horizon, your image stretching out across more and more time, your light growing dimmer and redder, until you seemed to freeze there forever, fading like the last light of a sunset that never quite finishes setting. Both of these things are true at once. You, falling, experience an ordinary rush of time. They, watching, see you drawn out into something like eternity. Time is not one shared river here. It bends around gravity the way a stream bends around a stone, and depending on where you're standing, you see a different shape of the same water. Isn't that a strange comfort? That somewhere, some version of this moment, you, resting, listening, letting go of the day, might look completely different depending on who's watching. And that neither version would be wrong. There is something else worth resting on for a moment. As you fell closer, gravity would begin pulling on you unevenly. The part of you closer to the black hole would be tugged harder than the part of you farther away. Your feet, say, pulled more strongly than your head. Scientists, with their fondness for gentle understatement, call this tidal stretching. The rest of us might just call it the long, slow story of being stretched like a thread being pulled from both ends. For most black holes, especially the smaller ones, this stretching would become unbearable long before you ever reached the horizon. You'd be pulled thin as a strand of starlight well before crossing over. But here's the surprising part. For the very largest black holes, the supermassive ones that anchor entire galaxies, this stretching is so gentle, so gradual, that you could cross the horizon itself without feeling much of anything at all. The bigger the black hole, the gentler its edge. It's a small, quiet irony worth carrying with you. The largest, most overwhelming things in the universe are sometimes the softest to actually meet. Sometimes, what looks most intimidating from a distance turns out, up close, to be the easiest thing to simply fall into. There is something else worth resting on for a moment. At the very center of a black hole lies something we call a singularity, a point where our equations, the very tools physicists use to describe reality, simply stop working. Density becomes, in the math, infinite. Space and time, as we understand them, lose their meaning entirely. This isn't scientists giving up. It's scientists being honest. We've built beautiful, careful maps of how gravity behaves, maps that work perfectly almost everywhere in the universe. And at the singularity, the map runs out of paper. We don't actually know what's there. Some suspect it isn't truly infinite at all, but rather a place where a deeper theory, one blending gravity and the strange rules of the very small, would need to take over and finish the sentence our current physics can't complete. There's a quiet kind of peace in admitting we don't know something. You don't have to have every answer tonight, either. Some things, a decision, a memory, a feeling you can't quite name, are allowed to stay a little unfinished, resting at the edge of understanding, without demanding to be solved before you sleep. There is something else worth resting on for a moment. Inside the event horizon, something genuinely peculiar happens to the very geometry of space and time. Ordinarily, you can move freely through space, left, right, forward, back, while time only ever marches one direction, pulling you along whether you like it or not. But past the horizon of a black hole, these roles begin to swap. The inward direction, toward the singularity, stops behaving like an ordinary direction in space and starts behaving like time itself, something you cannot pause, cannot reverse, cannot simply choose not to move through. In other words, once you're inside, reaching the singularity isn't a place you travel to. It becomes something more like an appointment with next Tuesday, not somewhere you go, but something that simply happens to you, the way tomorrow happens to all of us, regardless of how we feel about it tonight. There's an odd comfort in that, too. So many things in life feel like far-off places we must struggle to reach. But some things rest morning, the slow settling of a hard day, arrive on their own schedule, the same way tomorrow always eventually arrives, whether or not we finished worrying about today. There is something else worth resting on for a moment. Not all black holes are the same size, and the difference is almost impossible to picture honestly. A black hole formed from a collapsed star might have an event horizon only a few miles across, small enough, in principle, to fit within the borders of a modest city. You could, in theory, orbit its darkness the way you might drive around a lake. But the supermassive black holes that live at the centers of galaxies are almost beyond imagining. Their event horizons can stretch wider than our entire solar system, wider than the distance from the sun to every planet you've ever heard of, combined, and then some. If you tried to picture standing at the edge of one, the curve of its darkness would be so vast you might not even perceive it as an edge at all. Simply an ordinary, endless-seeming dark sky. Our own galaxy has one of these giants quietly humming away at its very center, a black hole millions of times heavier than our sun, sitting there in complete silence, while everything else, planets, stars, comets, and every quiet night you've ever spent looking up, orbits gently around it. The way a room slowly, sleepily turns around the one lamp still lit inside it. There is something else worth resting on for a moment. For a long time, black holes were something we could only describe in equations, beautiful on paper, invisible to the eye. Then, a handful of years ago, an enormous international effort linked telescopes together across the entire planet, essentially turning the whole Earth into a single giant eye, just so it could squint hard enough to catch a glimpse of one. What they captured wasn't quite the black hole itself. You can't photograph true darkness against true darkness. What they captured was its shadow, a dark circle carved out of a glowing, swirling ring of hot gas, and light bent so severely around the black hole's gravity that it wrapped almost all the way around, like a halo worn slightly crooked. It took our entire species working together, and technology developed over generations, just to draw the outline of something we'd only ever known through the quiet certainty of mathematics. There's something moving about that, how patient curiosity, carried by enough hands over enough years, can eventually let us see the edge of a shadow that light itself can't escape. There is something else worth resting on for a moment. Some black holes don't sit quietly. Some are surrounded by what's called an accretion disk, a wide, flattened swirl of gas and dust and shredded starlight, spiraling inward the way water spirals toward a drain. Except this drain is made of gravity instead of plumbing. As this material spirals closer, friction and pressure heat it to staggering temperatures, hot enough to glow brilliantly, hot enough to outshine entire galaxies of ordinary stars, all from a region smaller than a single solar system. In a strange twist, the very edge of the darkest thing in the universe is often surrounded by some of the brightest light we can observe anywhere in the sky. It's a little like how the quietest people sometimes end up at the center of the liveliest rooms, not because they're loud themselves, but because everything simply gathers and glows around them. Whatever quiet thing lives at your own center tonight, let it rest there, undisturbed, while everything else swirls gently down and settles. There is something else worth resting on for a moment. If a black hole is spinning, and most of them are, some extraordinarily fast, it doesn't just sit in space. It drags space around itself, the way a spoon stirred through honey drags the honey along with it. This effect has a lovely, quiet name: frame dragging. Space itself gets pulled into a slow, inevitable spiral around the black hole's rotation. Around a spinning black hole, there's even a region called the ergosphere, where this dragging becomes so severe that nothing, not light, not matter, not even empty space, can remain still. Everything there is forced to move, swept along in the black hole's slow, cosmic current, whether it wants to or not. Maybe you felt something like that today, swept along by a schedule, a conversation, a current of small demands you didn't choose. Tonight, though, you're allowed to stop being swept. Let the current pass by without you in it, just for now. There's something else worth resting on for a moment. You might think black holes only ever take pulling in light, matter, entire stars, and never giving anything back. But in the 1970s, a physicist worked out something quietly astonishing. Black holes actually leak, ever so slightly, releasing a faint trickle of particles now called Hawking radiation, named for the man who first calculated it. The effect comes from the strange rules of the very small, a place where empty space isn't truly empty, but simmers gently with pairs of particles flickering in and out of existence. Near a black hole's edge, sometimes one particle of a pair falls in while the other escapes outward, carrying away the tiniest sliver of the black hole's mass with it. Multiply that tiny sliver by an unimaginable stretch of time, and eventually, the black hole itself fades away. Even the most patient, gravity-bound darkness in existence is, in its own impossibly slow way, letting go, one small piece at a time. If a black hole can slowly release its grip over the eons, perhaps you can allow yourself to release a little of your own grip tonight, one small piece at a time, without needing to let go of everything all at once. There is something else worth resting on for a moment. The smaller a black hole is, oddly enough, the hotter and faster it evaporates. A vast, supermassive black hole is almost perfectly cold, radiating so faintly it would take far, far longer than the current age of the universe for it to fade away. A process so slow it makes geological time look hurried. A much smaller black hole, though, would run hotter and shed itself faster, eventually fading in a final, brief flash of energy. Somewhere in this quiet fact is a small piece of wisdom. The biggest things often take the longest, gentlest paths to their ending, while smaller things can flare and finish more quickly. Neither pace is wrong. Both simply belong to their own kind of size. There is something else worth resting on for a moment. For decades, black holes were something we inferred, but never directly heard. Then, in 2015, scientists detected something new. A ripple in the very fabric of space and time itself, arriving at Earth after traveling for over 1 billion years, caused by two black holes finally spiraling into one another and merging into a single, larger darkness. They call the detected signal a chirp, because when converted into sound, it rises quickly in pitch and volume before ending, not unlike a small bird's call or the last quick note of something settling into stillness. Two of the most powerful, gravity-dense objects in existence collided with a force beyond imagining. And by the time that event reached our instruments, it arrived as something almost gentle. A whisper, a chirp, a soft final note in an otherwise silent universe. Maybe that's true of some of your own biggest days, too, the ones that felt enormous while you were living them, and arrive later in memory as something quieter, something you can finally just listen to instead of carrying. There is something else worth resting on for a moment. Sometimes a star wanders too close to a black hole without falling straight in, and instead gets slowly, methodically pulled apart. Astronomers call this a tidal disruption event, though it might be more honestly described as watching a star get stretched into a long, glowing ribbon of light, wrapped gradually around the black hole like thread slowly winding onto a spool. These events can outshine entire galaxies for a brief while. A final bright farewell before the stars' remains settle into a swirling disk and are eventually drawn inward for good. It is, in its own strange way, one of the more beautiful endings the universe has invented turning collapse into light, if only for a little while. There is something else worth resting on for a moment. One of the deepest, most stubborn puzzles in all of physics is the question of what happens to information that falls into a black hole. Not information like a letter or a memory exactly, but something more fundamental. The underlying details that make up everything that falls in, the very recipe of it. Our best theories insist that information can never truly be destroyed, only rearranged. But if a black hole eventually evaporates completely through Hawking radiation, where does the information about everything that ever fell inside actually go? This question, quietly nicknamed the black hole information paradox, has occupied brilliant minds for half a century and still isn't fully resolved. There is a strange comfort in a puzzle that important people still haven't solved. It means not knowing isn't a failure. Sometimes it's simply where the frontier of understanding currently sits, patient and unfinished, waiting for someone someday to take the next quiet step forward. There is something else worth resting on for a moment. Physicists eventually discovered something unexpected. Black holes have entropy, a kind of measure of hidden information or disorder. And stranger still, that entropy depends only on the surface area of their event horizon, not on their volume. This is almost backward from how entropy works for anything else we know, like a room or a gas cloud, where more space usually means more room for disorder. This strange fact eventually inspired an idea called the holographic principle. The notion that everything that falls into a black hole, all its information, might somehow be encoded not throughout its interior, but smeared across the surface of its horizon, like a shadow holding more detail than the object casting it. Some physicists have taken this even further, wondering whether our entire three-dimensional universe might, in some deep sense, be a kind of projection from information written on some distant boundary reality as a very convincing shadow of something simpler underneath. You don't need to hold onto any of that carefully. Just let it sit there like a lovely, half-remembered dream. That maybe the universe keeps its deepest secrets not buried inside things, but written softly on their edges. There's something else worth resting on for a moment. Despite how complicated a black hole's history might be, whatever star it once was, whatever material it has swallowed since, a finished black hole can be completely described using only three simple numbers: its mass, its spin, and its electric charge. Physicists sometimes call this the no-hair theorem, a playful way of saying a black hole has no other identifying features, no matter how elaborate its past. Everything else, every story, every collapse, every star it ever consumed is smoothed away, forgotten by the shape it becomes. In some ways, that's a small mercy. However complicated the journey, whatever the object was made of before, it settles at last into something simple. 3 numbers. A quiet ending, stripped of all its old details. Maybe tonight, whatever complicated shape your day took, you're allowed to settle the same way, not forgetting it happened, just letting it simplify, letting the details soften into something small and quiet and easy to carry into sleep. There is something else worth resting on for a moment. Not every black hole comes from a dying star. Some physicists believe that in the earliest, most chaotic moments after the universe began, tiny regions of space might have been squeezed so violently that they collapsed directly into black holes. No star required at all. These are called primordial black holes, and if they exist, some scientists suspect they might make up part of the universe's mysterious dark matter, the invisible mass that seems to hold galaxies together, even though we've never directly seen it. We don't yet know for certain whether these ancient, starless black holes exist, but it's a quietly wonderful possibility that some of the darkness holding galaxies gently in place might be older than any star, born in the universe's very first, most private moments, before there was anyone around to notice. There is something else worth resting on for a moment. Some black holes don't stay quiet. They launch enormous jets of particles out from their poles, faster than almost anything else in existence, stretching for distances that dwarf entire galaxies. These jets are thought to form near actively feeding supermassive black holes, twisted into existence by furious magnetic fields tangled up in the swirling, superheated material just outside the horizon. When one of these jets happens to point directly at Earth, astronomers call the resulting bright, energetic object a blazar. One of the most luminous, persistent objects in the observable universe, powered by a black hole so far away its light has often been traveling since before our own planet fully cooled. There's something almost paradoxical and lovely in that. The very object defined by trapping light so completely can, under the right conditions, become the engine behind some of the most powerful beacons the universe has ever produced. There's something else worth resting on for a moment. Supermassive black holes and the galaxies that surround them seem to have grown up together. Their sizes seem quietly, mysteriously linked, as though each somehow shaped the other over billions of years. Some of the largest black holes we've found were already startlingly massive when the universe was still very young, barely out of its infancy, which is a puzzle scientists are still gently working to understand. It's a bit like discovering that a tree and the shape of the hill it grows on were somehow talking to each other the whole time, each one quietly influencing how the other turned out. A relationship far older and stranger than either one alone. There is something else worth resting on for a moment. You might imagine the nearest black hole to be impossibly far away, tucked safely at the edge of some distant galaxy. But astronomers have found one, nicknamed Gaia BH1, only about 1,000 light years from Earth, extraordinarily close. As these things go, quietly orbited by an ordinary sun-like star, the two of them locked together in a slow, silent waltz that neither one seems to mind. 1,000 light years still sounds enormous, and it is. But on the scale of a galaxy, 100,000 light years wide, it's practically a neighbor. A quiet, dark presence dancing gently with its companion star, not far at all, as cosmic distances go, from the very ceiling above your head tonight. There is something else worth resting on for a moment. There's a common misunderstanding about black holes worth softening tonight. It isn't that matter gets squeezed into some impossible, unimaginably heavy density in a way that breaks the ordinary rules of stuff. It's better to think of it as an extreme curving of space and time itself. Gravity so severe that the geometry of space simply folds in on itself, rather than any material becoming somehow more than solid. A black hole isn't crushed matter so much as it is warped space, wearing matter's memory like a very old photograph. The shape remains distorted, longer after everything else about it has changed. There is something else worth resting on for a moment. Here is something gently reassuring if you let it be. From your own point of view, falling freely toward a black hole would feel exactly the same as floating weightlessly, calmly, anywhere else in space. There would be no sensation of falling at all, no wind, no pressure, no lurch in your stomach. Free fall simply feels like stillness, because you and everything around you are falling together at exactly the same rate. This is one of the quiet, foundational ideas behind how gravity actually works. The realization that falling and floating are, locally, indistinguishable from one another. Wherever you are tonight, however heavy the day felt, remember that even falling, done gently and evenly, can feel indistinguishable from simply resting. There is something else worth resting on for a moment. Our best minds have wondered whether a black hole's interior might, in some deeply theoretical and still unconfirmed way, connect to somewhere else entirely. A tunnel through the fabric of space and time itself, sometimes called a wormhole. It remains speculative, unproven, more a mathematical possibility than an observed fact. No one has ever found one, and most physicists suspect that even if they exist, they would collapse too quickly, too violently, for anything to actually pass through. Still, it's a lovely thought to let drift by without needing to hold on to it too tightly. That somewhere in the equations describing the darkest thing we know, there's room left over for a door. there is something else worth resting on for a moment. Just outside the event horizon lies a thin, invisible shell called the photon sphere, the one place where light itself can be captured into a perfect, endless circle, orbiting the black hole instead of escaping or falling in. It's an unstable balance. The smallest possible push would send that light spiraling away or down into the dark. But for one fragile moment, light can simply go in circles, chasing its own tail around something it can never quite leave. There's something tender in imagining that even light, the fastest and most restless thing in the universe, can find one narrow place to simply loop and linger, caught in a slow, glowing ring instead of always racing somewhere else. Maybe tonight your own thoughts can borrow that same trick, circling gently, softly, instead of racing anywhere at all. There is something else worth resting on for a moment. A little farther out than the photon sphere lies another quiet boundary, called the innermost stable circular orbit. The closest a solid object can safely circle a black hole before gravity's pull becomes too uneven to hold a steady path. Any closer than this invisible line, and matter can no longer simply orbit. It begins, instead, to slowly spiral in. It's a bit like the outer edge of how close you can lean toward a worry before it starts pulling you in, rather than letting you simply consider it from a safe, steady distance. Tonight, you're comfortably outside that line. You can look at anything you like from here safely, without being pulled anywhere at all. There is something else worth resting on for a moment. If a black hole isn't spinning, its singularity is thought to be a single, dimensionless point, infinitely small. But if it's spinning, as most real black holes seem to be, the singularity is believed to stretch instead into an impossibly thin ring, spun outward by its own rotation, the way pizza dough spreads thin when it's tossed and twirled. Even at the most extreme, most crushed heart of a spinning black hole, rotation still leaves its fingerprint, a shape, however strange, rather than nothing at all. There's something oddly comforting in that. Even collapse, taken to its very limit, still carries the memory of the way it was spinning, the way old habits and gentle rhythms tend to linger in us long after everything else has changed. There is something else worth resting on for a moment. There's a precise, almost delicate threshold in the life of a dying star, named for the young physicist who first calculated it, the Chandrasekhar limit. Below this mass, a collapsing star's core can settle into a dense, glowing ember called a white dwarf, holding itself up by nothing more than the stubborn refusal of its particles to be squeezed any closer together. Above this same limit, that refusal simply isn't enough, and the collapse continues on toward something far stranger. It's a striking thought that somewhere between a peaceful ending and one of the strangest objects in the universe, lies a boundary so precise it can be written as a single, quiet number. Not every ending needs to be dramatic to matter. Some of the most important thresholds in the universe are also some of the gentlest. There is something else worth resting on for a moment. Before a star becomes a black hole, it sometimes pauses at an extraordinary in-between stage. A neutron star, so dense that a teaspoon of it would outweigh a mountain, held together by forces stranger than anything you'll encounter in ordinary life. Some neutron stars spin hundreds of times each second, sweeping beams of light around like a lighthouse built from a collapsed sun. Only when a neutron star is pushed even further by gathering more mass or colliding with another star does it finally cross its own last threshold and complete the journey into a black hole. Even the most transformative changes, it seems, sometimes need more than one quiet stage to finish unfolding. There is something else worth resting on for a moment. When a supermassive black hole is actively feeding, pulling in enormous quantities of gas and dust, the resulting glow can outshine every star in its host galaxy combined. Astronomers call these brilliant, voracious objects quasars, and in the universe's younger years, they were common enough to be some of the brightest, most easily seen objects across unimaginable distances. Somewhere out past the edge of easy imagining, ancient light from a quasar has been traveling toward us since before our own sun had finished forming. A beacon lit by hunger, still arriving long after whatever version of that black hole exists today has changed entirely. There is something else worth resting on for a moment. One of the earliest strong hints that black holes were real, rather than just an elegant idea on paper, came from a source in the constellation Cygnus, quietly devouring a nearby star and glowing brightly in X-rays as it did. The evidence was compelling enough that two famous physicists once made a friendly wager over whether it was truly a black hole. A bet eventually settled gracefully in the black hole's favor. There's something lovely about brilliant minds allowing themselves to be a little unsure, a little playful, even about something as serious as the nature of gravity's darkest creation. You're allowed a little uncertainty tonight, too, resting comfortably in not needing to have everything figured out before you sleep. There is something else worth resting on for a moment. For years, astronomers patiently tracked a single star, nicknamed S2, as it swept on a long, looping orbit around the invisible mass at the center of our galaxy, timing its path so precisely that they could calculate, without ever seeing it directly, exactly how heavy and how compact that hidden object had to be. This careful, decades-long patience eventually helped confirm what many had long suspected, and was honored years later with one of science's highest awards. There is something quietly moving in the idea of watching one star's patient repeating path for years on end, simply to understand something you'll never actually see. A kind of devotion not so different from returning night after night to a voice like this one, simply because it helps you rest. There is something else worth resting on for a moment. The dark shadow we photographed around distant black holes is actually a little larger than the event horizon itself, because light passing nearby gets bent so severely around the black hole's gravity that its true edge appears stretched outward, magnified by the very darkness trying to hide it. In a strange way, a black hole's silhouette betrays its own size, making itself look slightly bigger simply by bending the light around its edges. Perhaps some of your own harder days do something similar, looming larger in memory than they truly were, stretched outward at the edges by everything swirling around them. It's all right to let that stretched shape soften back down to its true, smaller size as you rest. There is something else worth resting on for a moment. The very first person to solve Einstein's equations and describe what we now call a black hole did so not in a quiet university office, but while serving as a soldier during the First World War, working out the mathematics from a military hospital bed, finished the calculation, sent it off, and died only a few months later, leaving behind an idea so complete that scientists are, over a century on, still confirming its smallest details. There's a certain grace in that. Some of the calmest, most enduring ideas in all of science were worked out in circumstances that were anything but calm. Whatever your own day looked like, you're allowed to end it here, gently, the same way that quiet, careful thinking can happen even in the middle of everything else. There is something else worth resting on for a moment. For decades after these strange collapsed stars were first predicted, no one had a good name for them, until a physicist, searching for something simpler than the technical descriptions being used, offered up two plain, ordinary words: black hole. The name stuck almost instantly, simple enough for a child to say, mysterious enough to make an entire field of physics sound like a bedtime story. Sometimes the plainest words are the ones that last the longest. You don't need elaborate language to describe how you feel tonight. Either tired, calm, ready to rest. Simple words are more than enough. There's something else worth resting on for a moment. When powerful particle colliders were built to study the smallest building blocks of matter, a few worried voices wondered aloud whether such machines might accidentally create a tiny black hole and swallow the Earth. Physicists calculated the odds carefully and found nothing to worry about. any black hole small enough to form in such conditions would be so unstable that it would evaporate away through Hawking radiation in far less than the blink of an eye. It's a small, oddly comforting fact that even our boldest, most ambitious experiments have been quietly, carefully checked against the deepest fears we could imagine and found safe. You're allowed to trust that the ground beneath you tonight is exactly as steady as it's always been. There is something else worth resting on for a moment. One gentle way to picture the event horizon is to imagine a wide, slow river approaching a waterfall. Far upstream, a boat can paddle against the current and make its way back to shore. Closer to the edge, the current picks up, faster than any boat could row against, and there's a precise line, invisible from the surface, past which turning around is no longer possible, no matter how hard you try. That line is the horizon, not a wall, not a warning sign, just a current that has quietly become too strong to fight. Some evenings feel a little like that current, too, pulling you gently towards sleep, whether you fight it or not. Tonight, you don't need to fight it at all. You're allowed to simply let the current carry you. There is something else worth resting on for a moment. Some of the largest black holes ever discovered are almost impossible to hold in the mind honestly. Objects so massive that our own solar system would fit comfortably within their shadow many times over, with room left to spare. One such giant, tucked in a distant, faint galaxy, is heavy enough that if it replaced our sun, its event horizon alone would swallow most of the solar system's planets. There's no need to fully picture something that large. Some things are simply meant to be gestured at gently, from a safe and comfortable distance, the way you might glance up at a night sky too vast to take in all at once before letting your eyes close anyway. There is something else worth resting on for a moment. Some black holes spin at a pace close to the ultimate cosmic speed limit itself, their outer edges whipping around at a significant fraction of the speed of light. And yet, from a little distance away, all of that violent motion resolves into something perfectly smooth and still. A simple, quiet, dark circle, hiding its own frantic spin behind an appearance of complete calm. Perhaps that's true sometimes for people too. A great deal of motion and effort happening quietly underneath, hidden behind a calm, steady surface. If your own mind has been spinning quickly today, you're allowed to let it look calm now, resting gently, even before it's finished slowing all the way down. There is something else worth resting on for a moment. Physicists have long wondered whether a singularity could ever exist out in the open, unshielded by any event horizon at all. What they call a naked singularity. Most current thinking holds that nature seems to have a quiet preference for modesty here, always wrapping its strangest, most extreme places behind a horizon, hidden from outside view. Scientists have gently nicknamed this idea cosmic censorship, as if the universe itself preferred to keep its rawest secrets private. There's something almost sweet in imagining the universe as faintly private about its most intense places, wrapping them carefully before letting anyone look. You're allowed the same kind of gentleness with your own rawest thoughts tonight. You don't have to expose every one of them before you're ready. Some things can simply stay softly wrapped until morning. There is something else worth resting on for a moment. One careful mathematician, working through the equations long before anyone had directly observed a black hole, proved something remarkable. That, under very general conditions, a collapsing star doesn't just possibly form a singularity. It must, inevitably, according to the mathematics alone. This proof, built from nothing but careful reasoning and geometry, later earned one of science's highest honors, decades after it was first written down. There's a quiet kind of certainty in that story, an idea worked out patiently on paper, trusted fully even before the universe confirmed it. The way you might trust that morning will come even during the darkest part of the night. There is something else worth resting on for a moment. Here's a strange comfort tucked inside all this vastness. Once you cross a black hole's horizon, the time remaining before reaching the singularity, from your own point of view, turns out to be quite short. Not endless, not eternal. A brief, finite span measured in your own experience, even though from outside, the entire event might appear to stretch across unimaginable ages. It's oddly reassuring in its own dark way. Even the most inescapable journey in the universe has an ending you can actually reach, rather than one stretched out forever. Whatever feels endless in your own life tonight, remember that most things, even the heaviest ones, eventually arrive somewhere. There's something else worth resting on for a moment. If you drifted close enough to a black hole, without quite crossing its horizon, the bending of light around it would become so extreme that you could, in principle, see the back of your own head, your own reflected light, having circled all the way around the darkness before finally reaching your eyes. Space itself would curve so sharply that looking forward and looking behind would begin to blur into the same direction. There's something almost playful in that image, light so patient and so bent that it eventually shows you yourself from an angle you'd never otherwise see. Sometimes a little distance and a little bending is exactly what it takes to see something clearly, even if that something is only you. There is something else worth resting on for a moment. When two black holes finally merge, the resulting single black hole doesn't always come to rest peacefully where its two parents met. If the merger happens unevenly, gravitational waves can be emitted more strongly in one direction than another, giving the newly formed black hole a sudden, silent kick, sending it drifting off through its galaxy at speeds that can outrun almost anything else in motion, carrying it quietly away from where it was born. There's something oddly moving about that, too, an ending that becomes, instead, a quiet, sudden new beginning, drifting off into the dark on a path nobody chose in advance. Wherever today has left you, you're allowed a gentle drift of your own now, off toward sleep, without needing to have chosen the exact path that got you here. There is something else worth resting on for a moment. Not every black hole stays anchored to a galaxy or a companion star. Some drift alone through the vast spaces between stars entirely. Invisible, untethered, detectable only on the rare occasion their gravity happens to bend and briefly brighten the light of a much more distant star passing directly behind them. Astronomers call this a wandering or rogue black hole, and by some estimates, our galaxy alone may quietly hold many millions of them, adrift and unnoticed. There's a strange, gentle solitude in that image, countless quiet travelers, moving alone through the dark for millions of years, noticed only for the briefest flicker when their path happens to cross the light of someone else. Even alone, even unnoticed, they continue on, steady and unbothered, the way rest can find you tonight, whether or not anyone else is watching. There is something else worth resting on for a moment. Long before Einstein, long before anyone had the mathematics to describe gravity-bending light, two thinkers working in the 1700s, one an English clergyman, one a French mathematician, independently wondered about something they called a dark star, an object so massive that its own gravity would prevent even light from ever leaving its surface. Using nothing but the ordinary physics of their day, they arrived, on paper, at a rough sketch of an idea that wouldn't be properly understood for another century and a half. There's something quietly humbling in that. How a good, patient idea can arrive a very long time before the tools exist to fully confirm it, waiting patiently in someone's old notebook for the rest of the world to catch up. There is something else worth resting on for a moment. At its heart, the reason nothing escapes a black hole comes down to something surprisingly simple. Escape velocity, the speed something needs to break free of a gravity well entirely. On Earth, that speed is fast, but achievable. Rockets manage it every year. Near a black hole, gravity is so concentrated that the required escape speed eventually surpasses the speed of light itself. And since nothing in the universe can travel faster than light, nothing at all can climb back out. Once past that point, it isn't magic, and it isn't even especially exotic mathematics. It's the same simple idea that lets a ball fall back down after you throw it, just turned up, patiently, gravity built upon gravity, until even light can't quite make the climb. There is something else worth resting on for a moment. Despite their fearsome reputation, black holes don't actually suck things in any differently than an ordinary star or planet of the same mass would. If our sun were somehow replaced today by a black hole of the exact same mass, Earth's orbit wouldn't change at all. We'd simply lose the sunlight, drifting on through a much colder, darker path around an invisible companion, at exactly the same safe distance as always. The danger of a black hole isn't its pull from far away. It's only real up close, at distances most objects, most stars, most planets will simply never wander into. From any respectful distance, a black hole is a remarkably calm, ordinary neighbor. There is something else worth resting on for a moment. You might think of black holes as places of perfect silence, and out in the vacuum of space, that's true sound can't travel where there's no air to carry it. But astronomers once discovered something wonderful. A giant black hole at the center of a distant cluster of galaxies was sending pressure waves rippling outward through the thin, hot gas that filled that cluster real sound waves, just far too low and far too slow for any ear to hear. When scientists raised the pitch enough to make it audible and shared the result, people around the world could finally listen to something like the deepest, slowest hum in the known universe, a note pitched dozens of octaves below anything a piano could ever play. Even the quietest places, it turns out, are sometimes humming a note too low for anyone to have noticed before. There is something else worth resting on for a moment. When two black holes finally merge into one, the newly formed black hole doesn't simply settle instantly into stillness. For a brief moment afterward, it rings, its shape wobbling and distorting, radiating away the last of its rough edges as gravitational waves. The same way a struck bell keeps vibrating for a moment after it's been hit, its tone slowly softening into silence. Physicists call this brief, settling moment the ringtone, and it's often the last, quietest note in the whole cosmic event. Two of the most violent objects imaginable, finishing their collision not with a bang, but with something closer to a fading chime. There is something else worth resting on for a moment. For decades, the equations describing two black holes spiraling together and merging were considered too complicated to fully solve. Until, in the mid-2000s, a handful of research teams finally managed to coax the answer out of some of the world's most powerful supercomputers, letting the numbers run for weeks at a time. That breakthrough opened the door to everything that came after, predicting exactly what a merger should look like and sound like, years before we ever detected one for real. There's something patient and hopeful in that story, 2 years of careful, unglamorous work, quietly preparing the way for a discovery that wouldn't arrive until long after the work itself was finished. There is something else worth resting on for a moment. When a well-known film brought a spinning black hole to the big screen a little over a decade ago, its visual effects team didn't simply guess at what it should look like. They worked directly from real equations, built new rendering software just to handle the extreme bending of light involved, and in doing so, accidentally produced results detailed enough to be published as genuine scientific research. A piece of popular entertainment, quietly, became a real contribution to the same science it was trying to depict. It's a lovely reminder that curiosity and careful imagination, even when it starts as a story, can sometimes wander somewhere true. There's something else worth resting on for a moment. Long before the 20th century, scientists had already worked out that gravity should bend and stretch light ever so slightly, even here, quietly, on Earth. In the late 1950s, using nothing more exotic than a university tower and carefully tuned equipment, 2 researchers measured this faint stretching directly, confirming that gravity really does change the color of light, even across a distance of only a few dozen feet. If gravity's fingerprint can be measured across the height of a single building, it's easier to imagine, a little more vividly, what it becomes at the edge of something as immense as a black hole. The same gentle effect, simply turned up again and again, until it becomes impossible to ignore. There is something else worth resting on for a moment. The satellites that quietly make GPS possible have to account for this same strange relationship between gravity and time, correcting their onboard clocks every single day to stay in sync with clocks down here on Earth's surface, where gravity pulls just a little harder. It's a small, practical echo of the very same physics that governs the edge of a black hole, playing out quietly, invisibly, every time a phone finds its way home. Somewhere above you tonight, in fact, a small satellite is making that same tiny correction, keeping time carefully so that everything down here continues running smoothly, unnoticed, while you rest. There is something else worth resting on for a moment. Our own galaxy and its nearest large neighbor are slowly, patiently drifting toward one another on a collision course that will unfold over billions of years. So slow that not a single star is likely to actually collide during the process. Somewhere far in that distant future, the supermassive black holes quietly anchoring each galaxy's center will eventually meet as well, spiraling together in their own turn, joining into something larger still. It's almost impossible to hold that kind of timescale honestly in your mind, and you don't need to. Just let the thought pass by gently, that even galaxies take their time, unhurried patient enough to let billions of years pass before their quietest, deepest centers finally meet. There is something else worth resting on for a moment. As matter swirls in the disk just outside a black hole, its brightness sometimes flickers in a strange, regular rhythm, rising and falling with a kind of pulse, nicknamed by some astronomers a cosmic heartbeat. These flickers can repeat with surprising regularity, offering scientists one more quiet clue about the size, spin, and inner workings of the darkness producing them. There's something oddly tender in imagining a heartbeat at the edge of something so extreme. Proof that even in the most violent regions of space, rhythm and repetition still find a way to exist. There is something else worth resting on for a moment. As matter falls toward the horizon, tidal forces don't only stretch it lengthwise, they gently squeeze it inward from the sides at the very same time, the same way toothpaste narrows as it's pulled longer out of the tube. Stretched long, squeezed thin, gravity reshaping everything that falls toward it into something narrower and longer than it ever was before. Perhaps some of your own harder days do something similar, stretching your patience thin in one direction while narrowing your focus in another. Tonight, at least, there's nothing left to stretch or squeeze. You're simply allowed to be exactly your ordinary shape again. There's something else worth resting on for a moment. Because a black hole's silhouette scales directly with its mass, two black holes of wildly different true sizes can appear almost the same size from Earth, simply because the far larger one also happens to be much farther away. The two black holes we've actually photographed, one at the heart of a distant galaxy, one at the center of our own, look nearly identical in our images, even though one of them could swallow the other's entire visible surroundings many times over. Size and distance, it turns out, can conspire quietly to make two entirely different things look the same from far enough away. A reminder that appearances, even honest ones, don't always tell the whole story underneath. There's something else worth resting on for a moment. Any light that falls into a black hole never leaves again, which means, in a strange and quiet way, a black hole is also a kind of one-way archive, holding onto the last image of anything that ever crossed its horizon, sealed away from the rest of the universe forever. Whatever fell in carries its own tiny, final chapter into the dark, unread by anyone else ever again. There's something both a little sad and a little beautiful in that. A place that remembers everything it has ever touched perfectly, privately, and shares none of it with anyone. Perhaps tonight you're allowed a few thoughts like that too, kept quietly to yourself, needing no audience at all, safe simply in having happened. There is something else worth resting on for a moment. In 1939, decades before anyone had proof that black holes were real. Two physicists worked through the mathematics of a massive star collapsing under its own gravity and found something remarkable. To a distant observer, the star would appear to slow, dim, and effectively freeze in place forever. Its collapse never quite finishing from the outside. For a long while afterward, scientists actually called these predicted objects frozen stars, a quieter, gentler name than the one that eventually stuck. There's something sweet about that older, forgotten name, the idea of something not vanishing exactly, but simply freezing mid-motion, held forever in one last, unfinished gesture. There is something else worth resting on for a moment. One of the strangest, most elegant discoveries about black holes is that the total area of their event horizon can never shrink, not through collisions, not through feeding, not through anything at all, at least not in classical physics. Two black holes merging will always produce a horizon with more combined area than the two had separately, never less. It's a rule so consistent that physicists eventually realized it behaves exactly like an old, familiar law from ordinary thermodynamics. The one that says disorder in the universe only ever increases, never reverses. There's something oddly reassuring in a rule that only ever grows, never shrinks, never quietly takes something back. Whatever you've grown or gathered today, a little patience, a little rest, you're allowed to trust that it stays with you. The same way a black hole's horizon carries forward and never gives back whatever it has been given. There is something else worth resting on for a moment. Physicists have worked out that a black hole's spin has a theoretical upper limit, a point at which it would be spinning as fast as its own physics allows, called an extremal black hole. No confirmed black hole has ever been observed spinning quite that fast, though some come remarkably close, whirling at speeds that would make anything solid tear itself apart long before reaching the same rate. Even here, at the very edge of what's mathematically possible, nature seems to leave a small, careful margin, never quite touching its own outermost limit. The way a held breath rarely reaches the very last possible second before it must, gently, be released. There is something else worth resting on for a moment. A spinning black hole doesn't just drag space around itself. Under the right conditions, it can also act like an engine, quietly converting some of its own rotational energy into the enormous jets of particles blasting outward from its poles. Physicists have a precise name for this elegant process, first worked out on paper decades before it was ever confirmed, describing how a black hole can power something as bright as a beacon, using nothing but the simple, patient momentum of its own spin. There's something graceful in that image, spin itself, ordinary rotation, quietly becoming light bright enough to be seen from halfway across the universe. Whatever quiet momentum has carried you through today, it's allowed to become something calmer now, gently, without needing to power anything else tonight. There is something else worth resting on for a moment. The gravitational waves we've detected so far have come from relatively small, nearby collisions, stellar mass black holes merging within reach of instruments here on Earth. But scientists are now building an entirely new kind of observatory, one meant to fly in space rather than sit on the ground, patient enough to listen for the far slower, deeper ripples made by supermassive black holes merging across entire galaxies. It hasn't launched yet. It's still being carefully prepared, one careful step at a time, for a mission that won't begin for years. There's a gentle kind of hope in a project built for a future none of its planners will fully see unfold, trusting patiently that the listening will still be worth doing, however long it takes to finally begin. There is something else worth resting on for a moment. To catch and confirm a single gravitational wave signal, it usually takes more than one detector, separate observatories, spread far apart across the globe, comparing notes on the exact same tiny ripple as it passes through each of them in turn. This careful teamwork lets scientists work out not just that something happened, but roughly where in the sky it happened, triangulated gently from thousands of miles apart. There's something comforting in that kind of quiet cooperation. Separate, distant instruments, listening patiently together, none of them needing to catch the whole story alone. There is something else worth resting on for a moment before any star is massive enough to end its life as a black hole. Its final moments as a supernova scatter heavy elements outward into space: carbon, oxygen, iron, calcium. The very same elements that would later gather into new stars, new planets, and eventually, quietly, into you. In a very real sense, whatever collapses inward into darkness first spends its last moments generously giving something outward. The iron resting quietly in your blood tonight, and the calcium settled patiently in your bones, once belonged to a star that lived and ended long before our sun ever began to shine. Some small, ancient part of that old light is resting here now, breathing slowly, listening to this very voice. There is something else worth resting on for a moment. For a long time, physicists could only infer a black hole's mass indirectly, by carefully watching how nearby stars or gas moved under its gravitational pull. When the first direct image of a black hole's shadow was finally captured, scientists compared its measured size against those older, independent calculations, and found the two methods agreed beautifully, each confirming the other, arrived at through entirely different means. There's something quietly satisfying in two very different paths, leading to the exact same gentle conclusion. A reminder that when the evidence lines up from more than one direction, you can rest a little easier trusting it. There is something else worth resting on for a moment. Between the smaller, stellar mass black holes born from dying stars and the truly enormous supermassive ones anchoring galaxies, there's thought to exist a rarer, harder to find middle category, intermediate mass black holes, tucked away in dense clusters of ancient stars. For years, they were mostly theoretical, a missing link scientists suspected must exist, but struggled to confirm. Only recently have astronomers begun finding careful, convincing hints of them, quietly hiding in plain sight. Not every important thing announces itself right away. Some of the most interesting discoveries take patience simply to notice they were there all along. There is something else worth resting on for a moment. Far in the future, longer from now than the universe has even existed so far, the stars will have burned out one by one, galaxies will have drifted apart, and for an unimaginable stretch of time, black holes may be nearly the only structures left in an otherwise cold, dark universe, glowing faintly on their own with the last trickle of Hawking radiation before even they, eventually, fade away completely. It's an ending too distant to worry about, too slow to rush toward. Long before any of that arrives, this moment, this quiet room, this slowing breath will already be finished, resolved gently, the ordinary, unremarkable way most nights end, with sleep. There is something else worth resting on for a moment. The playful word for that long, thin stretching of falling object undergoes near a black hole, spaghettification, was popularized by one of the most beloved physicists of the last century, who had a gentle habit of giving serious, unsettling ideas soft, almost funny names, as if a little humor made the strangeness easier to hold. It worked. Decades later, it's still the word everyone reaches for first. There's something worth borrowing in that habit tonight, giving even your heavier thoughts a slightly gentler name, just to make them a little easier to set down before sleep. There is something else worth resting on for a moment. It turns out there isn't just one kind of black hole in the equations, but a small, tidy family of them, each one a little more complicated than the last. A plain, simple black hole with only mass, one with mass and electric charge, one with mass and spin, and one, rarest and most complete, with all three at once. Real black holes in nature are thought to almost always belong to the spinning branch of this family, charge being far too fragile a thing for anything so large to hold onto for long. Even something as extreme as a black hole, it seems, comes in a small, orderly family tree, simple branches, each one just slightly more than the one before it. There is something else worth resting on for a moment. A feeding supermassive black hole doesn't just grow quietly in isolation. The fierce light and particle winds it produces can blow outward through its entire host galaxy, gently cooling or scattering the very gas that galaxy would otherwise use to form new stars. In this strange, roundabout way, the darkest object at a galaxy's heart quietly helps decide how brightly that galaxy will shine for billions of years afterward. There's something worth sitting within that. How the quietest, most hidden thing at the center of something enormous can still shape everything around it, gently, without ever needing to be seen doing so. There is something else worth resting on for a moment. In 2017, for the first time, scientists detected both gravitational waves and ordinary light arriving from the very same distant event. Two ultradense neutron stars colliding and merging. The collision forged staggering amounts of gold, platinum, and other heavy elements in a brief, brilliant flash. And in some such collisions, the merged remnant is thought to collapse further still, crossing its own final threshold into a black hole only moments after the two stars first touched. Some of the gold quietly resting in a ring or a coin somewhere near you tonight may have been forged in exactly this kind of collision. An explosion so far away, so long ago, that its glow had been traveling toward Earth since long before there were rings or coins or hands to wear them. There is something else worth resting on for a moment. Astronomers have found a clever way to measure how fast a black hole is spinning, even from enormous distances. By studying how its intense gravity distorts a particular, well-known signature of iron atoms glowing in the hot disk nearby. The faster the spin, the more severely that signature gets smeared and stretched by gravity, leaving behind a kind of fingerprint that patient scientists have learned to read. There's something lovely about that. Using the glow of a single, ordinary element, iron, the same element quietly present in your own blood, to measure the spin of something at the far edge of imagination. There is something else worth resting on for a moment. One particularly strange system, nicknamed for the string of numbers and letters used to catalog it, features a compact object, likely a black hole or its close cousin, launching jets of particles that don't travel in a straight line at all, but corkscrew slowly through space, processing in a wide, wobbling spiral, the way a dropped coin wobbles before it finally settles flat. Astronomers sometimes affectionately compare its shape, traced out over years of patient observation, to a very slow, cosmic corkscrew. Not everything, even something built from such extreme physics, needs to travel in a perfectly straight line to still be beautiful, or to still, eventually, settle down. There is something else worth resting on for a moment. While most black holes we found exist alone or in simple pairs, astronomers have occasionally spotted rarer systems where three black holes appear to be gravitationally bound together, orbiting one another in a slow, three-way dance that can last for ages before, eventually, any pair among them draws close enough to merge. These systems are wonderfully rare, and each new one found offers a small, valuable clue about how black holes gather, interact, and eventually combine across the long life of a galaxy. Some arrangements, it seems, are simply built to take their time, three patient partners, circling gently, in no particular hurry to become one. There is something else worth resting on for a moment. The very phrase event horizon wasn't coined by Einstein, or even by the physicist who first solved his equations. It came later, from another careful thinker searching for the right words to describe a boundary beyond which no event could ever be witnessed from outside. He borrowed the word horizon quite deliberately, the same word we use for the ordinary line where the sea meets the sky, simply extended outward into the strangest edge physics has ever needed to name. It's a comforting borrow, in its own way, the same soft word you might use watching a sunset, quietly repurposed to describe the edge of the darkest thing in the universe. There is something else worth resting on for a moment. To measure the mass of a distant black hole too far away to watch stars orbiting it directly, astronomers sometimes use a patient technique called reverberation mapping, watching how flickers of light from deep near the black hole take a little extra time to reach and illuminate gas farther out. The way thunder always arrives a beat behind lightning. By timing that small, careful delay, they can work out distances and masses that would otherwise be impossible to see. There's something soothing in that idea, too, using nothing but a small delay, a brief and careful pause between one thing and the next, to understand something enormous. Sometimes waiting a moment before responding tells you more than reacting instantly ever could. There is something else worth resting on for a moment. The star known as S2, on its closest approach to the black hole at our galaxy's center, whips around at speeds reaching several percent of the speed of light, faster than almost anything else we've ever tracked so precisely, completing a swing that would take an ordinary planet millennia in only a matter of hours. And then, just as quickly, it swings back out again, retreating to a calmer, more distant part of its long, looping orbit, patient until its next close pass, years later. Even the fastest, most extreme motion in the galaxy still finds its way back to a slower, gentler stretch of orbit. Whatever pace today demanded of you, there's a slower, calmer stretch waiting for you too, and you've already reached it. There is something else worth resting on for a moment. In the universe's early, crowded youth, brilliant quasars powered by feeding supermassive black holes were so luminous that their light still reaches our telescopes today, offering some of our very best clues about what conditions were like when galaxies themselves were still young and half-formed. Astronomers sometimes think of these ancient, blazing black holes as lighthouses, lighting the way toward a part of the universe's story that would otherwise be far too dark and distant to read. There's something fitting in that image. The very objects that trap light more completely than anything else in existence, doubling in their youth as some of the brightest guides we have back toward our own origins. There is something else worth resting on for a moment. Capturing that first famous image of a black hole's shadow took more than a clever idea. It took hundreds of scientists across dozens of institutions, years of careful coordination, and so much recorded data that it couldn't simply be sent over the internet. Instead, hard drives full of information had to be physically packed up and flown city to city, continent to continent, before all of it could finally be combined into a single, patient, quiet picture. There's something moving in that, an image of something utterly vast and inhuman, made possible only by an enormous, very human effort. Careful hands, packed suitcases, years of patience, all quietly working together simply so the rest of us could finally see. There is something else worth resting on for a moment. Photographing the black hole at the center of our own galaxy turned out to be even harder, in some ways, than photographing the much larger, much farther one in a distant galaxy. Because the gas swirling near our smaller, closer black hole moves so quickly, completing full orbits in mere minutes, that the picture was quite literally still changing while astronomers were trying to take it. Scientists had to develop entirely new techniques just to freeze that shifting, flickering motion into a single, steady image. There's something familiar in that struggle, too, trying to hold something still and clear in your mind while it keeps quietly shifting underneath you. Tonight, at least, nothing needs to hold still. You're allowed to let the picture blur gently into sleep. There is something else worth resting on for a moment. When a gravitational wave from a black hole merger sweeps past a region of space, it doesn't just pass through and leave things exactly as they were. The fabric of space itself is left permanently, faintly stretched, a tiny, lasting shift, too small to easily notice, but real. Physicists call this the memory effect, a quiet signature left behind long after the wave itself has moved on to somewhere else. Perhaps something similar is true of days and of voices and of quiet evenings like this one leaving behind some small, gentle shift, too faint to notice directly, long after the moment itself has passed on. There is something else worth resting on for a moment. From the very beginning, we've been imagining what it might feel like to fall, and it's worth remembering gently that this whole slow journey has been a thought experiment. You are here, safe, warm, nowhere near any edge of any horizon, except perhaps the soft one between waking and sleep, which is a far kinder threshold to cross. There is something else worth resting on for a moment. Above you, right now, the universe continues exactly as it has for billions of years, unhurried, steady, indifferent to deadlines and unfinished tasks and half-remembered worries. Black holes drift quietly at the centers of galaxies. Light bends gently around darkness. None of it needs your attention tonight. It was unfolding long before you arrived, and it will keep unfolding long after you've drifted off. There is something else worth resting on for a moment. Your own mind, in a way, is a little like the universe it's been imagining tonight, always trying to predict what comes next, always working quietly in the background to make sense of the day, sorting and softening and filing things away, even while you rest. That's simply what a mind does. It doesn't need your permission to keep working gently in the dark. You can let it continue on its own, low and unhurried, the way a river keeps moving even after everyone on its banks has gone quiet. There is something else worth resting on for a moment, and then we'll let this rest completely. Somewhere in our galaxy, a black hole is turning slowly in the dark, wearing 3 simple numbers as its only name, holding its light close, patient beyond anything we can really picture. It isn't going anywhere. It isn't waiting for anything. It simply is steady, silent, unbothered by time. You can let all of this soften now, the way steam softens into air. There's no need to hold any of it tightly, not the horizons, not the singularities, not the ancient light of stars that finished burning long before your grandparents were born. Let it all blur gently at the edges, the way the day itself is blurring now. Let your breathing slow a little further. Let your body sink, heavier and softer, into wherever it's resting. Let your shoulders release whatever they were still quietly holding. There is nothing left to remember, nothing left to solve, nothing waiting for you except sleep. Somewhere above you, the same sky that holds a black hole millions of times heavier than our sun also holds this quiet moment. Exactly as it is, you, resting, safe, unhurried, while the universe keeps turning gently on, the way it always has, the way it always will, long after tonight has folded softly into tomorrow. Your body already knows how to rest. Sleep well.